Why do I say this? Because the first project that I actually started from scratch, when I found delegated types, we implemented it for everything. Like everything had delegated types, nothing had inheritance, nothing had abstract classes, and it ended up being a mess.
You might not name it like that, but you probably have it in, or I would say maybe you probably have it in your own projects. And when you see it how it is, you say, yeah, that is something that I needed, or that is something that I might need to build with it. And Nicolas is an amazing speaker that I'm inviting him here to talk about this because it's a super nice topic. So applause for Nicolas.
So the talk, polytable inheritance, it's just a play word between polymorphism and inheritance patterns in Rails or programming on itself. It's not that nothing is called polytable inheritance actually in Rails. A bit about myself, I'm Nicolas Erlichman. I work as CTO at GoGrow, we're a software agency. From Uruguay, for those who do not know, we're a small country in South America. It took us like 12,000 kilometers in 22 hours to get here. And if anybody wants to find me in social media, those are the different links and stuff. So why am I talking about this topic? First, thanks to Greg, who's sitting up front, because we were talking about this last year in Rails World, and he kind of encouraged me / pushed me a bit to kind of present about this topic. Really because I really like polymorphism and I really like modeling. And modeling especially more than I like coding or anything in programming itself, I think is a problem that I prefer to solve the most. And modeling, as you may think, it can really get messy, especially when you're talking about inheritance, class hierarchies, and those kind of stuff. It's hard to solve those problems. Maybe not so hard in Rails than other languages, but still, it's not that easy. And unfortunately, relational databases don't support inheritance, so frameworks or whatever you code needs to have to work around that. And until a few years ago, Active Record only offered 2 ways to do inheritance in Rails, which was basically single table inheritance, which you mostly have used, and something called purely abstract classes. Until the pandemic, when DHH, May 2020, I don't know if you can see it, maybe got inspired by being in lockdown and decided to build a new stuff called delegated types. And although it has 5 years, I didn't discover it up until 2023, more or less. So it took me a while building that same thing myself before actually using it. So at first I thought I was the only one who didn't know about that or abstract classes, so I decided to just make a survey and just probably you don't see the numbers, but I could say around 80% of the people who responded got at least 4 years of experience doing Ruby on Rails. And everybody had heard about, used, or applied it in multiple projects, concepts of polymorphism, right? And lastly, for sure, ask if people were interested in this topic, and everybody said yes, except one single person that said that was not for them. So if you're around or you watch the recording, please reach out and tell me what you think. I'll really be interested in hearing that. Perfect. So what were the results of the survey? I asked 4 things. First, how much do you know on polymorphic relationships? Nobody said they never heard of them. And just a few tiny people said that they heard of them but never tried it. So topic already covered. Then we move into single table inheritance. Again, you start seeing a bit amount of people that said they never heard of them, but it's still the most widely known pattern. And then we start moving to purely abstract classes, where I was surprised we got 25% of the people who said they never heard about it or never applied to them. And as I expected, the last one, again, it's already 5 years old, but there's still 30% of people that never heard about it and over 50% never use it in a project. So the idea is now to cover each pattern, at least slightly explain them, how they work, when you should use them and not, and hopefully you get out an idea of when you should apply them in each project. So single table inheritance, not much to say. Pattern, Rails, multiple models, only one database table. We all use this. Just for those who haven't used it, let's assume we have a car and a truck as our main reality problem. We would say car and truck, since they share make and model, they're both vehicles. This would be kind of like our reality description. And if we use single table inheritance, we still have 3 classes, vehicles, cars, and trucks, but we only have 1 table with all the attributes, plus an extra type attribute, which be safe to make that non-nullable, so you don't end up with orphan classes that are vehicles, but are neither cars or trucks, unless you actually need it. So what are the benefits of that? It's super simple. We only have 1 table, so we don't have to be loading multiple tables of data. We avoid eager loading, and we got a unified place to get all the vehicles together if we need to just do pagination or sorting. So when you should use this? When does it make sense? It makes sense mostly when you have a little difference between the attributes. So if you have different classes, car and truck, they only have 1 specific attribute each. So you're trying to find out where your classes are almost the same in the attributes and maybe the constraints in the database, but they do have differences mainly in the behavior. Like you have different methods, different scopes, or like the methods are the same, but you just do different stuff with it. You often need to query across the hierarchy. Basically, we're just showing I need to get all the vehicles, no matter if they're trucks or they're cars. I need to get them both in just one, let's say, 1 less or 1 table. And the set of subclasses like car and truck doesn't change very often. We're not adding like boats, motorcycles, bikes all the time, because that's going to be a problem. So what are the downsides? Like this sounds kind of like good. One of the downsides is you end up with table bloat if you don't follow the useful rules, which is you got multiple specific attributes, you got only 1 table, you end up with a lot of nulls in your data table. Which, although it's not a problem for the database, and if you read patterns, you'll see that Oracle does a good thing when you move the attributes to the right, like MySQL, Postgres, they don't care if you're doing a bunch of nulls, that doesn't affect performance. But if you're a person, you have to read a huge schema with a bunch of optional columns, you don't really know which one applies to what, so it gets messy to start to work with that. You get awkward constraints, and this basically means that you cannot make something non-nullable when it only applies to cars or only applies to trucks, unless you start doing check constraints in the database saying, this is only non-nullable when this other field is like type is car, for example. Or you just rely on app-level validations, which is, of course, not good for making your database good, handling integrity. It's hard to maintain. At the start, it's super easy. Like if you only have a few types, you only have a few different columns. But if you start growing, you have to do migrations that maybe only apply to trucks, but you're handling the same table for car and trucks. So you're modifying everything. So that can get a bit messy. And as you are, and you start adding different types, that overhead gets like bad really, really fast. So this is an example. Maybe code is not that easy to read. It's kind of like a simplified extraction of something that we did for a client. So initially we only got jobs, but then the client decided to introduce franchise jobs, which they work almost exactly the same. The only difference, and you can see the table, the only difference is that, I don't think I can point with this maybe. Yeah, they only have a difference in having a franchise ID, which only applies for the franchise jobs. So we got a main class which has, I don't know, the different statuses, the special equipment that belongs to a user, a worker, and some validations. And it has some base methods of how to charge to a customer and how to pay the worker. And then specifically on the job, you got a total price, which is just the price for the job. And the franchise job just belongs to a franchise. You got a total price that is the price plus the fee from the franchise. Oh, sorry. And you get an extra method that is pay the franchise, right? So it's simple. You don't got many different things. And for now, at least, it didn't look that we're going to add new different types of jobs. So then we moved to purely abstract classes. And for those who didn't remember, there was like a 25% of people who said that never used them or never heard about it. And essentially what it is you have the car, truck, and you got that same problem that we had before. But now instead of having 1 table, you still have 3 classes, vehicle, cars, and truck. But now vehicle is abstract, so it doesn't really have a database table. And then you have cars and trucks with their own tables. They have the shared attributes, which are, of course, duplicated. And they have their own specific attributes. You might find this name class table inheritance if you read some of the Rails source code. But if you go to the Martin Fowler's definition in the, I forgot, like patterns of enterprise application software in Java, you'll find this is actually named concrete table inheritance, which might not be a problem if you're only using Rails, but as you start searching about how to implement these patterns, you might find some inconsistency between what you find in the internet for like general knowledge in OOP and what you find for Rails. So what are the benefits of this? We get really clean schemas because car now only has make, model, and body style. Trucks only has make, model, and bed type, which are the specific attributes. We can now say that body style is non-nullable in the table because we're not rushing with the data of trucks. And we have a shared API to put all the logic that is common to both in the vehicle class. So when should we use this? We use this mainly when the classes are different, like you have a lot of different attributes between them. Then we'll use it when we actually want those DV constraints to be good and we don't want to rely on like when this type or whatever. We actually need that integrity in the database, maybe because it's being accessed by an external system directly without actually using the objects that we have in Rails. And this is a particular thing is we usually only query on a specific subclass. So we only need cars or we only need trucks, but we don't usually need to get all the vehicles in one same place, which by the way, that vehicles, trucks may not be the right case for this. It's just as an example. And we need schema clarity, and this is because now cars and trucks, they have their own table definition that is easy to understand and use if we're being used by, I don't know, an analytics team, analytics pipeline, or maybe just an external system that needs to use it. So what are the downsides of this? Since we don't have a parent table to query like the vehicle class, we cannot use an offset limit schema that we would use in SQL just to get all the vehicles together with the right pagination or sorting. So we end up resulting in either having to do unions in SQL or having to manually stitch the data on in memory. We also have duplication, and we have to do coordinated migrations for anything that is general. Like if we need to change the attributes that belong to vehicle, both the different classes, now we need to make two migrations. One to change the car table and one to change the truck table, which make us just remember which things we need to be changing, and that just adds a bit of friction. And we cannot do a belong to abstract class in Rails. We can do that with vehicles in single table inheritance because we do belongs to vehicle, and then it doesn't matter if it is a car or a truck. But in Rails, if we want it to belong to an abstract class vehicle, then we need to use belongs to polymorphic, which adds a bit more complexity because now you need to remember that it's car, it's truck, and you're sharing like, you don't get a right directly ID, you need to get the type. So it adds a bit more complexity for this. So we have to do some workarounds in getting the data all together. So if you remember, we got a lot of people, like 25% said they've never heard about it or use it, and around 40% of the people said they've used it a couple times. But the funny thing is that everybody who has done Rails new app has used purely abstract classes because ApplicationRecord is just a purely abstract class. And you may not know it's just because it says primary abstract class, but if you go to the source code of the inheritance module, you'll see, besides I stripped all the comments and different methods, you'll see one method, primary abstract class, that besides checking a couple stuff, it just does self abstract class true, which is how you define a purely abstract class in Rails. So easy, we both use it even if we didn't know about it. And as an example, here's a code from Redmine. If you ever use it, it's kind of like a Jira, but like more simple in the UI and stuff. And here's your application record where they just have a like specific method that you shared between all the different methods, all the different classes, sorry. I had ones that were much more complicated, like GitLab's application record, but it gets too big, so it's hard to just show an example, but you can find any other open source project and you'll find their application record with multiple methods. Another example about this, it's GitLab's, again, user mentions. So they have a user mention. Here's GitLab doesn't use schema.rb, which I found by going to their source code. So you need to, I didn't know there's something called structure SQL file that you need to use. So yeah, this is not a right schema, but you can find it that there's no user mention table. Like we do have a class, but we do have specific tables for each of the different classes, which they all have the note ID, note ID, note ID, and like the shared attributes. But if you check the classes, you get user mention, which is an abstract class with some shared behavior for the user mention. And then you have each specific class where they do some, hey, this belongs to node, this belongs to issue, this belongs to merge request. And although belongs to node seems to be in all of them, there are more user mention classes than not all of them belong to node. That's why they still have it here. So then we move to the last one, and this stops, so I don't know how much time it's been, but delegated types solves kind of the problems that we just mentioned. Like we use single table inheritance, we get table bloat, we get like a bunch of null columns. This solves that problem if we have different classes. And it solves the problem that we had with purely abstract classes where we don't have a shared unified class to access and then just do like, get me a list of all the vehicles. This comes from the Rails source code for the definition, like the PR that defines delegated types. It's all uncommented in the source code, so you can go read that the class is really easy to read. But if you actually read this on Martin Fowler's definition, this kind of like relates to something called class table inheritance, like multi-class table inheritance. It actually is not, because this is not inheritance, and you'll see just a moment. So although the talk initially was only about inheritance, I later found out while reading all the source codes, of course the name already says this is a delegation, not inheritance, but well. So we get into the same problem, again, vehicle, car, trucks. Now what we have is we do have 3 classes still, but now we have 3 tables in the database. So we still have the car and the truck, only with their own specific attributes. And we have the shared vehicle class, which has the make and model, which are general attributes. But now we introduce it polymorphism because we need to have that vehicle ID or vehicle type to know which is the record and car or truck. So it's just a middle ground between purely abstract classes and single table inheritance, which sounds really, really good, but can also get you into a not huge problem, but like a huge headache. So I already kind of like discovered this Scooby-Doo monster, which is delegated types. There's a lot of magic just to say behind that, but actually it's just a polymorphic association. That's why when Lucian said you probably already implemented that, it's probably true because behind the curtains, it's just a polymorphic association, and you can see it here, belongs to polymorphic, and an extra some sources, methods, classes, scopes, and you can, I don't know, check if your delegated type is of which specific type, you get finders. But most of all, it's not only code, so delegated types to me at least is more than just the way that you can do it in the code, and it's just more like a pattern that you can apply. Because you won't only find that code, you also need to add some extra stuff that are not part of delegated type. Like you'll do your own concerns that you add them to the different classes and stuff. So it's more a pattern than just what you got in Rails' code. So when should you use them? The first thing would be, as me, use them all the time. So now you don't have the problem of single table inheritance. You don't have the problem of purely abstract classes. You just use it for everything. Well, not really. And you'll use it when you have significant attribute diversion. So if you have a lot of different columns, same as purely abstract classes, you want specific guarantees in the database, specific constraints. Again, same as purely abstract classes. You want schema clarity, still same as purely abstract classes. But the only difference that you have with purely abstract classes is that you really do need to query, like get all the data from the different classes in one same place, right? So what are the downsides? Why not use it all the time? First, it's trickier to query attributes across the classes because now you have polymorphism. So if you want to get attributes across the different classes, you need to start doing it that yourself. You run a risk of doing n+1s just because you got that extra model that now you need to include all the time that you want to have all their data. You have more moving parts because now you have the different classes that you always need to have both. And it's not really truly inheritance. You need to manage it yourself. So it's not that you know, like in single table inheritance, that your car inherits from vehicle. Here you don't really know anything. You just apply some polymorphic relationship. So an example taken from Maybe's before they closed the open source version and now they started doing like a B2B thing. You'll see that you have the accounts table. They have an accountable ID and accountable type. And then again, there are more than this, but the accountables can be a credit card, an investment, cryptos, vehicles, and a bunch of different other stuff. So how do you find this? In account, you just put delegated type, the name, and you pass the just array of types. And you usually add some extra stuff like you accept nested attributes so you don't have to be creating credit cards specifically. You usually, and this is recommended by Rails guides, add a concern that you can reuse in all of the different classes to add that shared behavior, which usually just has one account and any other different thing that you have. And you can list all your different types so it's easier to add here. One thing to have in mind here is that delegated types won't actually check that you're relating the right things. So although you're putting this as types here, if in your code at some place you say that the accountable of an account is a truck or it's just another user, delegated types won't actually give you an error. So you don't really have those constraints. You have to implement it your own. So there are some other stuff that you can apply. So if you think about it, you probably already use polymorphic associations with different types, and you probably already needed to do this. You just didn't use any Rails-related extra thing to do that. You did it all yourselves, as we all do. There are also some gems that implement this. And lastly, just to end, quick rule of thumb that we need to when to decide which one to use. And it's a rule, so you have to use it all the time. Of course not. First, if we have like 80 or 90% of the attributes that are shared between the different classes, again, the differences are mainly in the behavior that we have, and we do need to query across the whole classes altogether, then use single table inheritance. Again, it's the easiest that you're gonna set up. Just beware that if your classes start growing, you're gonna need to refactor out of it. Then if your classes actually differ significantly in their attributes and you don't really need to query all the different types together, then as you may know, use purely abstract classes. And if and only if both things are kind of like true, like you have different attributes and validations and you often need to query all the records together, only now use delegated types. And why do I say this? Because the first project that I actually started from scratch, when I found delegated types, we implemented it for everything. Like everything had delegated types, nothing had inheritance, nothing had abstract classes. And it ended up being a mess because now, I don't know, we use ActiveAdmin. ActiveAdmin does not easily allow you to create the joint records with the polymorphic associations. So there are more moving parts that now you need to handle, now you need to worry about. You still got more migrations to do everything. So it's not harder to maintain, but it's harder to maintain if you don't really need it. And single table inheritance is super easy. You'll all use it. It's not a problem until it is a problem. And that's why DHH kind of like founded that they needed to use this. This is just a brief introduction. I initially wanted to show you a bunch more like source code, which is really interesting, specifically for the inheritance module, which I recommend you to do and read the Martin Fowler's book, even if you have to read through Java code, which is awful. But if anybody's interested about talking about these topics, just let me know. I'd be happy to talk about afterwards. So yeah, thank you. And if you want to download the slides, you can scan the QR code and here's my information. And as somebody suggested right before the talk, I'm going to add a bunch of resources that I use to build all of this to the slides that are published. Maybe take me until next week to update them. But yeah, that's already live and you can use it if you want to. Thank you.
Thank you. Any questions for Nicolas about this topic?